So today we're looking at the polynomials test review worksheet. Polynomials test review worksheet. I recommend that you try these problems on your own first, and I'll go through them briefly here so you can check your answers. Okay, number one, determine the maximum number of zeros for the polynomial. So the degree of the polynomial tells us the maximum number of real and imaginary zeros. So in number one, where I see negative 7x to the fourth, that 4 tells me the maximum number of zeros is 4. 2. Use appropriate notation to describe n behavior for each polynomial below. Okay, so in 2a, where I see a 2.9x to the fourth, positive leading coefficient, even degree polynomial, we say both ends go up. So as x heads to infinity, f of x heads to infinity. And as x heads in the opposite direction towards negative infinity, doesn't matter, function is still headed both ends up, right? We've got that sort of up, parabola-like experience. Part B, we're given x to the fifth. As our leading term, we see a positive leading coefficient for an odd degree polynomial. Descend up, descend down. So as x heads to infinity, f of x is also headed to infinity, right? As we go this way, this goes up. And as x heads to negative infinity, f of x heads to negative infinity as well. As we go this way, the function is going down, down, down. All right, and what about C? C says negative x squared. Well, negative x squared, both ends go down. So as x heads to infinity, f of x is headed down, 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 negative infinity. And as x heads to negative infinity, doesn't matter, f of x is still headed towards negative infinity. All right, there's problem 2. Problem 3. 3 says write in vertex form and graph. Okay, so let's just be clear. Yes, I'm happy to write in vertex form, but my recommendation is that you be comfortable with graphing these from general form. Remember, from general form, ax squared plus bx plus c, we want to do minus b over 2a to find the x-coordinate of the vertex. Then we'll take this number and plug it in to find the y-coordinate of the vertex. After that, there's our y-intercept, and we could, of course, use symmetry to find a third point. But let's imagine the universe where, you have to rewrite this in vertex form. So, part A, I'm looking at f of x equals x squared minus 2x minus 5. All right. Now, I'm supposed to write this in vertex form, which means I need to find the vertex. So, x equals negative b over 2a. And so I get 1. If I take that 1 and plug it into my function, f of 1 is going to be 1 squared minus 2 times 1 minus 5. And so f of 1 is negative 6. So my vertex is is 1 negative 6. So let's pull out vertex form, a x minus h squared plus k. Here's my h, here's my k. So we've got y equals a x minus 1 squared minus 6. Now, what about that a value? Well, it turns out, and it's always true, that the a value in this general form is in fact the same a value here. And since we have 1x squared, that's just going to be a 1, and there's my vertex. Do we have to graph this? Yes, and graph. Okay, so graphing from vertex form, I'm going to plot that vertex, 1, negative 6. I'm going to put a 0 in for x to find the y-intercept. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 times 1 is 1. 1 minus 6 is negative 5. And so 0, -5. And then with symmetry, I can find that third point. The distance from here to here is 1, so the distance from the middle to the other end should also be 1. And so I get to -5. Okay? That's graphing from vertex form. We could also graph from our general form here, where we do minus b over 2a. Hey, I did that already. And I got 1, and then I need f of 1, and I plugged that 1 in, and got -6. And so that process of rewriting, yeah, we just did that. So, yeah, either way, comes out the same. How about b? In b, we're told that f of x equals 2x squared minus 4x minus 2. Again, I need to put this in vertex form. So, minus b over 2a. 4 over 4, again, I get 1. F of 1 is going to be 2, 1 squared minus 4 times 1 minus 2. Those will cancel, and I'll have minus 4. So there's the vertex, and we see the y-intercept. So, and our a value. So y equals our a value, x minus 1 squared minus 4. There we go. Now, if I want to graph this, I've got a vertex at 1, -4. I have a y-intercept at 0, -2. If this distance is 1, then this distance must also be 1, so that'll be 2, -4. Okay? Let me know if you have questions about these. 4. Graph each, explain how they are transformations of y equals x to the third. So when I look at a, I see y equals negative x plus 2 to the third. Well, I see two transformations going on in here. One, inside the function, I'm moving left 2. And here, outside the function, because I'm multiplying all the y's by -1, this flips across or reflects across the x-axis. Because I multiplied the y's by -1, I'm going across the x-axis. So we will multiply the y's by -1 and subtract 1 from the y's of our reference graph. And we are asked to graph it. So let's start with those points, -1, -1, 0, 0, 1, 1. I'm going to multiply the y's by -1, and I'm going to subtract 2 from all the x's. And so I've got -3, 1, -2, 0, -1, -1. So my graph, no. I like that better. We want to see a flat slope right at that point. So I've got -3, 1, I've got -2, 0, and I've got -1, -1. Okay? It's not a positive x to the third, it's a negative x to the third. We flipped it. Okay? Part B, still working with y equals x to the third, but this time we've got y equals 2x minus 3 cubed minus 1. So what do these transformations do? Well, this one shifts the graph right 3. And here I have two y transformations. I'm supposed to multiply the y's by 2. That vertically stretches the graph. And subtract 1 from the y's. Oh wait, was I supposed to subtract 1 from the y's and then multiply by 2? What was the order in which we needed to do those? That's right, the answer is PEMDAS. I need to do the multiplying before I do the subtracting. If I have two transformations inside the function, that's where I want to be doing SADMAP. But outside, I'm going to vertically stretch by a factor of 2, and then shift the graph down 1. Okay, so how do we carry out those transformations so we can graph this? Well, let's start with the reference points, -1, -1, 0, 0, 1, 1. I'm going to multiply the y's by 2. I'm going to add 3 to all the x's, because remember, inside is opposite land. We're shifting right 3. So this is going to give me 2, -2, 3, 0, 4, 2. I still need to come back and subtract 1 from all the y values. So I get 2, -3, 3, -1, 4, 1. All right, and my graph. That point is 3, -1. This point is 4, 1. And this point is 2, -3. And you're, of course, welcome to put in the x and y axes if you want, but I find it's much easier to draw the appropriate shape and then throw some points on it, especially since we have excellent points here. All right, let's see what's next. I've got number 5. Write an equation for each. Well, all 3 of these are parabolas, and in A and B, I see the vertex. So I'm going to be using vertex form. In C, I see the x-intercepts. So I'm going to use intercept form. A, we're told that the vertex is located at 1, -2, and we've been given the y-intercept of 0, -1. So we'll start with y equals a, x minus h squared plus k, and we'll put in our vertex. So y will equal a, x minus 1 squared minus 2. That's right. So what about a value? Well, that's why we've got this y-intercept to work with. If we plug in the y-intercept, I've got this. Be careful with this. -1 squared is 1a minus 2. A lot of people want to combine these things, but this has an a and this doesn't have an a. So I can't combine them. Instead, I'm going to add 2 to both sides and get that a equals 1. So what's our equation? Y equals 1, x minus 1 squared minus 2. And since a is equal to 1, you could just leave it off if that was your preference. All right, B. We're given the same sort of information in part B. We're given a vertex located at 2, 6, and a second point, a y-intercept of 0, 4. So we'll start with a, x minus h squared plus k, and we'll plug in our vertex, y equals a, x minus 2 squared plus 6. And now let's plug in our y-intercept. Doesn't have to be a y-intercept, any other point other than the vertex we've just used, any other point. Do make sure that's an x and that's a y. So don't put 0 here, put 4 here. A 0 minus 2 squared plus 6. 4 equals 4a plus 6. Right? This is -2 squared, which is positive 4 times a, plus 6. No, you can't join them. Has an a, does not have an a. You could subtract 6 from both sides. You get -2 equals 4a. Again, at this point, there's some people who come up with an a value of -2. Those people should slow down and show the step, because they're more likely to realize, oh, no, not -2, -1/2. So y equals -1/2, x minus 2 squared plus 6. Hey, also notice, when you look at that graph for B, that parabola is flipped upside down. It opens down, so I need a -a. If you don't have a -a and you're looking at that picture B, you got a mistake somewhere that you need to go find. All right, let's take a look at 5C. I had mentioned that I wanted to use intercept form because I've got both x-intercepts here. 3, 0, and a third point as well, 0, negative 2. Intercept form, remember, is a, x minus b, x minus c, where these are our x-intercepts. So y equals a, x minus a minus 1, x minus 3. Or y equals a, x plus 1, x minus 3. Now I'm going to plug in my extra point. My y-intercept fits nicely here. So I've got 1 times negative 3. So I've got negative 3a. See, these are all multiplied together. So I can do that. Equals negative 2. And if I divide both sides by negative 3, I get that a equals 2/3. Positive a value makes sense to me here, where we see an up-pointing parabola. So y equals 2/3, x plus 1, x minus 3. Ta-da! All right, so let's take a look at number 6. Number 6 says, graph this polynomial. There we go. Graph this polynomial. Y equals x plus 2 to the third, x minus 1 squared. In fact, why don't you try that one right now? Okay, so I know there's a wiggle at negative 2 and a bounce at 1. This is a 5th degree polynomial, so I know that I'm down on this end and up on this end. That's right, there's a positive leading coefficient. This would be x to the third times x squared, that's positive x to the 5th. So what do I have to do at negative 2? I have to wiggle. And I have to bounce at 1. Remember, I also want to see the y-intercept graphed. How do we find a y-intercept? Same as we've been doing it since Algebra 1. We plug a 0 in for the x's. So I'm going to have 2 to the third, which is 8, and negative 1 squared, which is 1, equals y. So 0, 8 is our y-intercept. Okay, what about b? b, y equals x plus 2 squared, x minus 1 to the third, x minus 4. Well, here I see a 6th degree polynomial. 2 plus 3 is 5, plus 1 is 6. I don't see any negative x's to worry about, so this is going to be both ends pointing up with an x-intercept at negative 2, at 1, and at 4. Both ends go up. We know there's a bounce at negative 2. We know there's a wiggle at positive 1, and passing through at 4. Don't forget to label the y-intercept by plugging a 0 in for all these x's. That's going to be negative 1 times negative 4, positive 4, times 2 squared, or 4, so we get 16. Okay, problem 7. 7 says, what's the equation for this graph? Well, when I look at that graph, I see a wiggle at negative 1, and I see a bounce at positive 3, but I don't know my a value, and that's what I'm going to use that y-intercept for. That point 0.27 I'm going to use to find my a value. 27 equals a, 0 plus 1 to the third, 0 minus 3 squared. Or 27 equals a, 1 times 9, not 0.99. So if I divide both sides by 9, I get that a equals 3. So our polynomial looks like this. Please do not FOIL this out. No, just leave it like this and walk away. Okay, part B. Part B says we've got a bounce at -1 and a wiggle at 3, but we don't know our a value. So let's plug in the ordered pair 0, -27 and see what happens. -27 equals a, 0 plus 1 squared, 0 minus 3 to the third. Well, that's negative times negative times negative. I'm going to get -27 times 1 equals -27. So I guess a is just 1. So that's my equation. All right, that was 7. Let's take a look at 8. 8 says the demand for handheld gaming devices depends on the price. Nintendo determines that the number of micros they can sell is modeled by D equals -5m squared plus 630m minus 40, where m is the price of the micros in dollars. And D is demand. That means how many people want to buy. M is the number of micros where M is the price per micro. Okay, M equals dollars per micro, and D equals demand. Fabulous. At what price will the demand for micros be a maximum? Well, look, we've got this. So we know it's this. And where is demand a maximum? Here at the vertex. So I'm going to say that D equals minus B over 2A. And so I get 63. Where M is the number, 63 is the demand, but we don't know if that's tens, hundreds, thousands, millions. We're just told that this is demand. Okay. Wait, D, 63. Why are those dollars? Oh, there's a typo for you. So we like the answer B, kinda, because we got the 63. But the 63 is the number of gaming devices. So I seem to have made a mistake here. In this case, where these are all dollars, I choose E, because this is a number of micros, not dollars at all. Yeah, that determines the number where M is price per micro. At what price? Oh, wait a minute. I made the mistake. Remember, the ordered pair here is M, comma, D. The demand depends on price per micro. Price per micro, not number of micros. Oh my goodness, $63 was correct, and this is B. And so what does this remind me of? Well, it reminds me that when we were in the functions unit, we had to pay close attention to what our inputs and outputs were. And just because we've left the functions unit doesn't mean we should stop thinking about that. All right, 9. Farmer has 248 feet of fencing. They want to enclose a little garden along a river, length, width. And what does she want to do? She wants to find the area of this rectangle as a function of x. And they say that x is the one parallel to the river. Okay, so area equals length times width. But wait a minute, we were asked for area as a function of x, not as a function of x and something else, just x's. So if I had a helping equation, I could take that helping equation and solve it for w, and then replace what w is equal to from that helping equation in there. So let's see if we can come back here and come up with a helping equation. Well, yeah, we haven't used this number yet. What does this represent? This plus this plus this. So 248 equals 2 W's and an X. And what do I want to get rid of? I want to get rid of W, so I want to solve this equation for W. I'm going to start by subtracting X, and then I'm going to divide by 2. So I get 124 minus 1 half X equals W. And that's what I'm going to plug in there. So I'm going to have X, 124 minus 1 half X. Great, we've got area in terms of X. Now it says for what value of X makes area the largest? Well, if I distribute here, I'm going to have negative 1 half X squared plus 124X. Look, it's a downturned parabola. So let's think about that downturned parabola with intercepts at 0 and 248. Right? Because if I set this equal to 0, I get that 1 half X equals 124, because I'm going to add this to the other side. X squared. X squared. Oh, no, I'm up here. Sorry. Here's where I am. I'm setting this factor equal to 0. 124 minus 1 half X equals 0. And so I'm going to add 1 half X to both sides. And so I'm going to get 124 equals 1 half X. If I multiply both sides by 2, I get 248 equals X. 48. So I know my intercepts are at 0 and 248. I know it's a down-pointing parabola. And I know that halfway in between, I have 124. That's going to be the X value that produces the maximum area. What value of X makes the area largest? Yeah, there it is, 124. Halfway between the X intercepts. Of course, that was doing the problem just with factored form, with, intercept form. But, we could also find that X coordinate of the vertex by doing X equals minus B over 2A. And sure enough, I get positive 124. So I've got 2 ways I can address that problem. We're not asked for the dimensions. We're not asked for the maximum area. All we want to know is what X value makes that maximum area occur. Okay, number 10. 10 says the height of a mortarboard thrown at graduation is given by h of t equals negative 16 t squared plus 48 t. Height, t seconds after it's released, so that's height in feet, and that's time in seconds. Find the maximum height of the mortarboard. Well, remember, the input is time, and the output is height. And so when they say, find the maximum height, we want to know that maximum height. We may need to find out when the maximum height occurs, so we can plug that in for t to get the actual maximum height out. Now, you'll notice that I jumped quickly to this picture, and the way I did that was I factored out a GCF here. And so I had intercepts at 0 and at 3. I know halfway between these two x-intercepts is 3 halves. 0 plus 3 divided by 2. If I want to know what the height is at 1.5 seconds, I'm going to have to put that 1.5 in there. Now, we could do h of 3 halves equals negative 16, 3 halves squared plus 48 times 3 halves. But I'm not going to do that because we just talked about synthetic substitution. And so I've got negative 16 and I've got 48. So I bring that down, I multiply. Negative 16 divided by 2 is negative 8. Negative 8 times 3 is negative 24. And I add those and I get 24. Ta-da! I know that h of 3 halves is 24 because I remember what the remainder theorem was talking about in this polynomial's unit. So the maximum height is 24 feet. How else could we do this? Well, we could come up here to this general form and say, all right, t equals minus b over 2a. And so we could get negative 48 over negative 32, which, by the way, turns out to be 3/2. And so then I'm going to take the 3/2 and plug it back in, either like this, ew, fractions, they say, or with synthetic substitution. All right, what's next? Ooh, long division for number 11. Let's take a look at number 11's long division. Part A says x squared minus x plus 1 into negative x to the 4th plus 3x to the 3rd minus 4x squared plus 3x plus 5. Oh my goodness. Yeah, can't do this with synthetic. Can only use linear factors in synthetic. So x squared to make negative x to the 4th. Well, I'm going with negative x squared because negative x squared times x squared is going to be negative x to the 4th. Don't forget to distribute that negative x squared to each of these. We get positive x to the 3rd minus x squared. In long division, we subtract. 3x to the 3rd minus x to the 3rd is 2x to the 3rd minus 4x squared minus a minus 1x squared is going to be minus 3x squared, and bring down that plus 3x. What do I multiply this by to turn it into that? That's going to be a 2x, and then I'm going to take that 2x and distribute it to each of those. I'll have 2x to the 3rd minus 2x squared plus 2x. Don't forget we're subtracting. These cancel. Minus 3x squared minus a minus 2x squared is negative x squared. 3x minus 2x is going to be 1x. And bring down that 5. What do I multiply this by to turn into that? How about a negative 1? I get negative x squared plus x minus 1. And when I subtract, I'm left with 6. So we can say negative x squared plus 2x minus 1 plus 6 over, remember, remainder over divisor, x squared minus x plus 1. So there's my answer to 11a. What about 11b? Well, isn't it interesting that 11b is a long division problem? I suspect the teacher is thinking about whether their students will remember the 0 placeholders. Right? Right. You need those 0 placeholders. What do I multiply r by to turn into r to the 3rd? I'm going to need r squared. Distribute that r squared and subtract. 0 minus 3, negative 3r squared. Bring down that plus 0r. What do I multiply this by to turn it into this? Negative 3r. So now I'm going to have negative 3r squared. Don't forget negative 9r. And we subtract. 0 minus a minus 9 is positive 9r. And don't forget to bring down that 27. What do I multiply this by to turn it into that? I've got a plus 9. So we have 9r plus 27, and when you subtract, we have a remainder of 0. So that is our quotient, the result of doing that division. Now, remember that r to the 3rd plus 27 is a sum of cubes, and that factors as r minus 3, r plus 3, r squared minus 3r plus 9. Behold, r plus 3, r squared minus 3r plus 9. What I was looking at here was this over this, but this factors like that, and we can cancel those out. So that's what I'm supposed to get, and that's what I got, so I'm a happy camper. Problem 12 says use synthetic division. Okay, we've got negative 3x to the 5th minus x to the 4th plus 3x squared plus x minus 7. And we're supposed to divide all of this by x minus 1. Okay, so we don't divide with factors, we divide with x-intercepts. So we've got to do that inside is opposite land thing. I've got negative 3, I have negative 1, I have 0. Look, there are no x to the thirds here. You have to remember that 0 placeholder. Come on. 3, 1, and negative 7. Negative 3, negative 4, negative 4, negative 4, negative 1, negative 1, 0, 0, negative 7. So what do I get? Well, I have negative 3x to the 4th minus 4x to the 3rd minus 4x squared minus 1. What? I feel like I'm missing something. 4, 3, 2, 1. No, that didn't work. What happened? Did I miss another 0 placeholder? 5, 4, 3, 2, 1, 0. They're all there. I'll put that down. I added. Yes. I added. Yes. Negative 1. 0. Oh, that's right. This is x to the 5th, so this has to be x to the 4th, x to the 3rd, x to the 2nd. Oh, that's a remainder. Silly me. Okay, so that's correct. No x to the 0 power, but minus 7 over x minus 1. Remainder over divisor. So that's my quotient. All right, is there a b? There is indeed a b. So for part b, we've got 2, 3, negative 3, 0 placeholder, negative 6, 8. It's almost as though the problems were set up to continually remind you about 0 placeholders. I wonder why that is. 12, 6, 12, and 20. Okay, so this was 3x to the 4th, so I've got 3x to the 3rd plus 3x squared plus 6x plus 6 plus 20 over x minus 2. Okay, there's our quotient. What's next? Ooh, use synthetic division to determine which of the below are not factors of this polynomial. So yeah, with this polynomial, I can't factor by grouping. And maybe I'm too lazy to pick up my calculator, so I'm just going to use synthetic division. I see the factor x minus 2, but since I'm doing synthetic division, that means I use x equal to 2. 2, 1, negative 5, negative 2, negative 24. 1, 2, negative 3, 6, negative 8, 16, negative 8. Why, look, a remainder that's not 0. So that one doesn't work. What's the next one? Ooh, negative 3. Negative 3. So I bring down the 1, negative 3, there's negative 8, there's positive 24, there's positive 22, times a negative 3 is negative 66, and that's not going to be 0. So negative 3 doesn't work. How about negative 4? So I bring down the 1, negative 4, negative 9, 36, 34, no, 120, 136? No, that doesn't work. So our last choice is 3. So let's try a positive 3. 3, negative 2, negative 6, negative 8, 0. So x minus 3 is a factor. Damn, they said which is not factors of. But we showed that 3 of them didn't work. Oh, well, maybe that means I'm supposed to check all of those. I'm just going to quick graph this polynomial, x to the 3rd plus 5x squared minus 2x minus 24, nice. Zoom standard and C. 1, 2, 3, 4. Huh, that's funny. Negative 3, negative 4, and positive 2 all look like they do work. What am I missing here? X to the third. Oh, look. That's a plus. Wah, wah. So, that's what happens when you rush. So let's try those numbers again. 2. I'm happy that synthetic division is so fast. So 2 works. Yay. What about negative 3? Negative 3, 2, negative 6, negative 8, positive 24. 3 works, a negative 3 works as well. And if we try a negative 4, negative 4 plus 5 is 1. There's negative 4, negative 6, 24, 0. That one works as well. So all of these are x-intercepts, and the only one that isn't then is x equal to 3. So the factor x minus 3 is not a factor, especially when you copy down the problem correctly. Okay, that's a good lesson to learn. 14. Use synthetic division to determine f of negative 3. Well, this is our opportunity to use synthetic substitution. Negative 3, we have 1, 3, 0, 5, negative 9, 0, negative 24. Really, you have to pay attention to those 0 placeholders. There are no x to the firsts here. There are no x to the fourths here. 1, negative 3, 0, 0, 0, 0, 5, negative 15, negative 24, positive 72. 72 times 3 is going to be negative 216. And when I add these, I get negative 240. So what's f of negative 3? Negative 240. And that is sure a whole lot faster than me plugging that negative 3 into all those x's and figuring out what all that stuff is equal to. All right, 15. Annual carbon emissions in Canada are modeled by W of x equals 6x to the third minus 3x squared plus 8x minus 84. Okay, where x is the number of years since 2002 and W is the number of metric tons of carbon Canada has thrown into the atmosphere. Use synthetic division to find out how much carbon was released in 2015. Does that mean I plug a 2015 into those x's? No, 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 because they said x is the number of years since 2002. So let's subtract, and we get 13. So what I'm looking for is W of 13. And we might normally plug a 13 into each of those, but we've been told here in the directions that we're supposed to use synthetic substitution. And so I'm going to divide in 3, 8, negative 84. 6, 78, 75. 75 times 13. Oh! 13 times 75. Well, I guess that's 10 times 75 plus 3 times 75. And so we end up with 975. 975 plus 8 is 983. Oh my goodness, 983 times 13. 983 times 13, and I get 12779. If I subtract 84 from that, because I'm adding a negative, I get 12695 metric tons. That's a lot of carbon to throw up in the atmosphere. Yeah, maybe we should throw a little less. So, synthetic substitution. It'll save time. You just have to remember it. 16. Write the numbers a and b that make the equation true. We've got a minus 7 plus b minus 3i equals negative 2 plus 6i. And remember when we talked about complex numbers in that video, we said, look, the real part has to equal the real part, and the imaginary part has to equal the imaginary part. If you want to have the i's, go ahead, but the first thing I'm going to do is divide by the i's. So I'm just looking at b minus 3 equals 6. So b has to equal 9. And here, I see that a has to equal 5. When a is 5 and b is 6, these things are equal, and therefore that statement is true. So that would be my answer to problem 16. 17. 17 says that negative 5i minus 3i squared simplifies to which number? Well, we remember that I squared is negative 1. Negative 1 times negative 3 is positive 3. I still have this minus 5i. There's nothing I can do about that here. And I see 3 minus 5i is choice D. D for number 17. What about 18? Ooh, simplify each. So for part A here, in number 18, we see square root of negative 20 times square root of negative 6. So I want to do square root of negative 1 times square root of 20 times square root of negative 1 times square root of 6. And we know these square roots of negative 1 are called I. So I've got an I times another I times 20 times root 6. We can actually combine these into one radical. But we'll probably want to simplify that. That's 2 times 5 times 2 times 3. Looks like I could take a 2 out. So I'm going to pull that 2 out, and there's I times I, or I squared. So 2I squared, square root of what's left over? 10 times 3, 30. And what's I squared? That's right, negative 1 times 2 is negative 2 root 30. That's what I get for part A on number 18, negative 2 root 30. Now, some people, when they do this problem, they do this. And I just want to see, does this get us the same answer? They say negative 20 times negative 6. They say square root of 120. And they say, well, that's going to be 2 times 2 times 30. And so they have 2 root 30. But that's not our answer. So guess what you can't do? You can't do that. That's why my first move was to pull out those imaginaries. I wrote it as square root of negative 1 times square root of 20 times square root of negative 1 times square root of 6. You must do that, or you end up with the wrong answer. So, it's my recommendation. B, square root of negative 147 plus square root negative 108. Well, this is divisible by 7. This is 7 times 21. 21 is 3 times 7. So I got a pair of 7s that can come out, or a 7 can come out, and see those negatives? I'm just feeling all twitchy that I haven't taken them out already. So we've got 147 square root times square root of negative 1, and another square root of negative 1, and a 108. So that's going to be I. This is 7 times 7 times 3. We're going to pull out a 7, so 7I root 3. Now what about over here? That's I. And this, well, isn't that 12 times 9? Yeah. And 12 is 2 times 2 times 3, and 9 is 3 times 3. So I can take out a 2, I can take out a 3. 2 times 3 is 6i that comes out, and I have only a 3 left over. Look, I can do the subtraction. I end up with 7 minus 6, or 1i root 3. And no, I wouldn't write the 1, but that is my answer there. All right. Problem 19. Ooh, we're multiplying complex numbers now. Let's take a look at multiplying for problem number 19. We've got negative 2 plus 3i. We've got 4 plus 3i. And I FOIL minus 6i plus 12i plus 9i squared. Remember, I squared is negative 1. Negative 1 times 9 is negative 9. There's a negative 8, so I got me a negative 17. And here, minus 6i plus 12i is 6i. So there's part A. Part B, we have 10 minus 3i squared. We're not simply going to apply the squaring. We're going to write this as 10 minus 3i times 10 minus 3i, so that we get all the terms. 10 times 10 is 100, minus 30i, minus 30i, plus 9i squared. I squared is negative 1, times 9 is negative 9, plus 100 is 91, but here we also have minus 60i. If you just apply this, you get 100 plus 9i squared. Great, but what about the middle terms? So, no, that is evil. Don't do that. Write it as a thing times itself and do the FOILing. Okay, what's next? 20. 20 says that we're supposed to rationalize the denominator and then write the answer in standard form. 7 plus 4i over 5 minus 2i. Okay, so let's use our conjugate. 5 plus 2i, 5 plus 2i. And yes, I got a bunch of FOILing to do. On top, 35 plus 14i plus 20i plus 8i squared. Right? 20i, 8i squared. On the bottom, 25 minus 10i plus 10i minus 4i squared. Negative 2 times positive 2 is negative 4. I times I is I squared. So how can we tidy it up? Well, I squared is negative 1, so that's negative 8 plus 35 is going to be 27. 14 plus 20i is 34i. Now on the bottom, my i's cancel. I squared is negative 1 times negative 4 is positive 4 plus 25 is 29. Remember, when we rationalize the denominator, there should be no imaginary numbers left down there, and there aren't. Now, it did say we should write our answer in standard form. So I'm going to be okay with this, but really, standard form is a plus bi, where we split this into two fractions. That's really standard form, okay? So I'll be okay with this, but, U of N math placement test, they want that. Okay, what do we have left? 21, solve using the quadratic formula. We've got 3x squared plus 3x equals negative 5. So remember, I can't use the quadratic formula unless this is set equal to 0. So 3x squared plus 3x plus 5 equals 0. Now I can use quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's tidy this up. This is 12 times 5, which is 60. Ooh, negative 60. 9 minus 60 is negative 51. Plus or minus, we've got a negative 3 over 6. So, yeah, don't leave that there. How about negative 3 plus or minus I root 51? 51 is divisible by 3. But it's 3 times 17. I don't have a pair of anything here, so I'm leaving that as 51 and over 6. You could split this into two fractions. Negative 3 over 6 plus 1/6 I root 51, and then turn that into negative 1/2 plus 1/6 I root 51. But why? I mean, what does that get me? It's still imaginary. I'm still not going to graph it. Yeah, mostly I just don't want you canceling those, right? Because that root 51 needs that 6 under it. So no, don't do that. Okay. What's next? We've got 22. Graph with exact x-intercepts. F of x equals x to the third plus 3x squared minus 4x minus 12. Hey, that's factorable. I can do factor by grouping there. I pull out an x squared, I have x plus 3. I pull out a negative 4, I have x plus 3. I factor out that GCF, and I'm left with x squared minus 4. A difference of squares. So we've got x plus 3, x minus 2, x plus 2. Everybody has a multiplicity of 1. Check it out. 3 factors for x to the third. Nice. And so we graph. We've got negative 3, we've got negative 2, we've got positive 2. This is a positive x to the third, so woo, here we go. And don't forget to label the y-intercept. There it is. So we've got negative 12 there, and a 2 here. Okay, any questions about that one? What's next? 23, find all the zeros. And we're given the function f of x equals negative 7x to the fourth plus 252x squared. And you know what I'm thinking? I'm thinking not only can I take out an x squared, but I'm betting 7 goes into that. Let's find out. 3, 1, 42, 36 times. So I'm going to pull out a negative 7x squared, which will leave me x squared minus, right, because I'm doing this divided by negative 7, so I get minus 36 left over. Oh, a difference of squares. Negative 7x squared, x minus 6, x plus 6. Okay, and what are we looking for here? Find all the zeros. So when we set this polynomial equal to 0, that means negative 7x squared equals 0, and x minus 6 equals 0, and x plus 6 equals 0. Well, here I'm going to divide by negative 7 and take the square root, and I'm going to get 0. I'm going to get 6, and I'm going to get negative 6. Those are the zeros for this function. Don't forget the balance at x equals 0. All right, 24, find all the real roots. And this thing I cannot factor by grouping. So we've got 24x to the third plus 32x squared plus 14x plus 2. And yeah, what do? What is it that I'm supposed to do when I have to factor this polynomial with 4 terms, but grouping doesn't work? That's right, I'm supposed to be in this century, not that old century where we do the factors of this over the factors of that and a hell of a lot of synthetic division. Instead, we're just going to come over here to our calculator and say, please, little calculator, will you help me find some roots? Plus 14x plus 2. Okay, and if I graph that, is that negative 1/2? I think that might be negative 1/2. I'm going to change my viewing window. I'm going to go negative 2 to 2, and I want the scale to be 1/2. Okay. Oh, there's something happening there. I think I got too much y. I'm going to change the y and go negative 2 to 2. So what's going on here? Whoa! Do you see? Oh my goodness, it's wiggling at -1/2. Well, wait a minute. Is it really? Let's see what happens. If I do -1/2, I'm going to have, 24 times -1/2 is 20 times -1/2 is 4 times -1/2 is 0. Yeah, -1/2 worked, but it should work again. That's -12, that's 8, that's -4, and 0. And what's this? 24x plus 8. Well, that's going to be 24x. Whoa! That's not 1/2. That's -1/3. 8, 24. Now 1/3. Is it really 1/3? Whoa! You mean it's got to bounce at there? No, I must have made a mistake. I'm just going to go back and check for a second. 24, 32, 14, 2. Remember 24, -1/2. That's good. That's 20. -1/2 times 20 is -10. I get a +4. I get a -2 and a 0. That's great. I do -1/2 again. I bring this down. -1/2 times 24 is -12. Plus 20 is 8. -1/2 is -4, and that is 0. But that's 24x plus 8, and that's going to be -1/3. Whoa! So how come I don't see it here? Well, let's change that y scale again. Right? We've got from -2 to -1. What if I make that be -0.5 to +0.5? Now I see something's happening there. I've got a bounce at -1/2 and a pass through at -1/3. Whoa, Mr. Kukla, that's so harsh. Yeah, I agree. That's pretty tough. Now, some of you will just do that -1/2 and see that it's a 0, and then you'll move to turning this into a polynomial. 24x squared plus 20x plus 4. We still need to factor that. But look, everybody's divisible by 4. So we've got 6x squared plus 5x plus 1. Now, how does this factor to make that? Well, 2x, 3x, 1, 1, plus, a stretching factor, and don't forget that. There's an x equals -1/2. There's a second one. I got a bounce. Here's my x equals -1/3. Okay, so you know why that problem was designed the way it was? Because if we do zoom standard, it looks like a wiggle at this place. And then people just write down, oh, the only x-intercept is -1/2, when it turns out -1/2 and -1/3. Ooh, thinking. Okay, so it looks like we only have two problems left. One, we're supposed to use the fact that -5 minus 2i is a root of x to the third plus 15x squared plus 79x plus 145. So let's see. This times these and add. Now I need this times these. -5 minus 2i times 10 minus 2i. That's going to be -50 minus 20i plus 10i plus 4i squared. So that's going to be -10i. I squared is -1 times 4 is -4 plus -50 is -54. So that's -54 minus 10i. When I combine like terms, I have 25 minus 10i. And finally, I'm going to take this -5 minus 2i and multiply by 25 minus 10i. Okay, so minus 5 times 25 is minus 125, minus 50i plus 50i plus 20i squared. I squared is negative 1 times 20 is negative 20, plus that is negative 145, and the middle terms cancel, and we're really happy because we get a 0 here. But remember, complex roots always travel in conjugate pairs. So if you've got this one, you also have this one. 1 minus 5 plus 2i, oh look, they cancel. 5, negative 25 plus 10i, 0. And so we're left with x plus 5. And what are we looking for here? We want the other roots. So x equals negative 5. Our other roots are negative 5 and minus 5 plus 2i. These are the other or remaining roots. This was the one they gave us. Okay, last problem is identify the third degree polynomial with real coefficients and zeros at 1 for plus I. Hey, and you know, they always travel in conjugate pairs for minus I. Well, I'm going to turn these into factors, x minus 1, x minus 4 plus I, x minus 4 minus I. Don't forget to distribute. And so we have x minus 1, x minus 4 minus I, x minus 4 plus I. Now, I'm a fan of doing these first, not because I want to get the hardest stuff done out of the way, just because it's a lot worse if you do these first. So I'm going to have x squared minus 4x minus xi minus 4x plus 16 plus 4i plus xi minus 4i minus I squared. So can we combine anything? Plus 4i minus 4i minus xi plus xi. Minus 4 minus 4 is going to give me x squared minus 8x. I squared is negative 1, but there's a negative in front of that, so negative 1 times negative is positive 1, plus 16 is 17. And that's what we want to FOIL with x minus 1. Right, and I'm going to need to do that so that I can see what that FOIL form is. So I'm going to have x to the third minus x squared minus 8x squared plus 8x plus 17x minus 17. So that's x to the third minus 9x squared plus 25x minus 17. Choice D. Alrighty, well, I hope this was helpful for you, and let me know if you have any questions before you take the test. Take care, everyone.